Quadratics, factoring. You've been doing factoring for a long time. You probably started doing it in third grade, so it will probably be helpful for us to review what it is. When it comes to factoring whole numbers, you may have heard the phrase prime factorization. This phrase simply means that we are going to express or write a number as the product or multiplication product of prime numbers. Let's look at example 1. Find the prime factorization of 24. So you remember maybe these factor trees where you break this up and you say, well, I can do 6 times 4. I know that's 24. And 6, well, that can be 2 times 3. And 4, that's 2 times 2. And these are all prime numbers, meaning that the only thing that they're divisible by are 1 and themselves. 2 and 1, 3 and 1, and so on. So that's how prime factorization works. Now, we often rewrite this prime factorization as, we could write it as 2 times 2 times 2 times 3, and that's just fine. But it's also helpful to write it as 2 to the third power times 3. And that's really probably the way that you learned how to do prime factorization. In addition to factoring numbers, we can also factor algebraic expressions. When we do this, we inspect each term to see if there is a or are factors, are common factors. One method for factoring algebraic expressions is the box method. That is, thinking of the expression as the area and the factors as the length and width of a rectangle. So we're going to look at examples 2 and 3. Factor the expression 4 plus 20x is example 2. So using the box method, we have the expression 4 and 20x. So this is 4 plus 20x. And then on the outside, we're going to write the factors. So the area of this part is 4, and the area of this part is 20x. 4 and 20 are both divisible by the common factor 4. Now, 4 divided by 4 is 1. Let's do that in a different color. 1. 20x divided by 4 is 5x. So we can see that 4 times 1 is 4, and 4 times 5x is 20x. So the height of this rectangle is 4, and the length of this rectangle is 1 plus 5x. So we can rewrite our original expression as 4 times the quantity 1 plus 5x. And so this is the original expression factored. Okay. Similarly, we'll do this one here. So we have a negative 6 and 9x. So this is negative 6 plus 9x. Both of those terms, negative 6 and 9x, are divisible by 3. Negative 6 divided by 3 is negative 2. 9x divided by 3 is 3x. So we can rewrite our original expression as 3 times the quantity negative 2 plus 3x. And that's factored. All right. It's important to notice that factoring algebraic expressions is the opposite of expanding. Expanding. You've probably heard it called distributing, and distributing is a kind of expanding. And you can also use the box method in expanding. So we're going to practice, and we'll look at expanding the expression. So here we have an algebraic expression. We're going to expand it. So we're going to have this rectangle, and it's broken up into two parts because this expression has two parts, two terms. We're going to have the negative 4x. Well, let's do that a little bit smaller, a little bit neater. There we go. And then this. And so what we have is we have negative 4x, and we have negative 3x plus 5. So inside the this is the height, negative 4x. For this rectangle, the length is negative 3x. So we do negative 4x times negative 3x is positive 12x squared. Negative 4x times positive 5 is negative 20x. So we can rewrite our original expression as 12x squared minus 20x. We can also think of it as distributing. Negative 4x times negative 3x is 12x squared. Negative 4x times positive 5 is negative 20x. If you want to do the distribution just like that, instead of using the box, that's just fine. You can definitely do that. All right, let's practice factoring one more expression. Example 5 right here. This one's a little bit tougher. Of course, it's the last one. As usual, we're getting a little bit harder as we go. So when we're factoring, we put the expression inside the box, 30x minus 25x squared. So what are these two terms divisible by? Well, they are both divisible by 5. Not only 5, they're also both divisible by x. Okay, so here we're going to do 5x. So 30x divided by 5x is 6. Negative 25x squared divided by 5x is negative 5x. So we can rewrite our original expression as 5x times the quantity 6 minus 5x. Now notice that the thing that we put up here that we're multiplying by, we have to put that in parentheses because we're multiplying 5x times all of it. And the way we show that is with parentheses. All right, so that is quadratics, factoring.